Hello everybody, welcome to this class of organic chemistry, and in this we shall discuss one very important point, that is boiling point and melting point of haloalkanes and haloarenes. Also we shall discuss in this class the stability of haloalkanes. Now these things are extremely important because this will determine the properties of haloalkanes and they will be required later on very frequently. If you know all these things here, then it will give you the result in subsequent classes, subsequent chapters, where almost in everywhere haloalkanes and haloarenes will be discussed, and each time you don't have to suffer if you read this thing, if you understand these things here properly. And moreover, if you understand these things for haloalkanes and haloarenes, then you will be able to apply this type of things in other compounds also. So it is very important to understand how the melting point and boiling point of any compound differs and what are the factors which contribute most towards the melting point and boiling point of any compound. Now first of all, before going to melting point and boiling point, we shall just briefly discuss what are the physical states of any compound. For any compound there are three states, namely solid, liquid and gas. Now in solid the molecules will be very closely packed, but if we consider liquid, the molecules will be little bit far away from each other. Now if we move to this, what the basic change takes place among these? The molecules will remain the same, only difference will be that these molecules will be far away from each other. So intermolecular distance gets higher, and so this is now gas. Now if we have to explain the melting point and boiling point, now before going to this, what is melting point, what is boiling point? Let us consider this change. In this process, the solid will be converted into liquid, not at every temperature, but for that a certain minimum temperature will be required, and the minimum temperature at which any solid melts to form liquid is called melting point of that solid. Similarly, if we convert liquid into gaseous state, then the temperature required to convert this liquid into gaseous state is called its boiling point. Now I am not going in details here, so many criteria are there. Pressure is also one important factor, but just here we are not going in details in it. Now one thing you have to know here, if the attractive force between these molecules, maybe between these molecules, maybe between these molecules is greater, then what will happen? Since they are under high force, so they will be very reluctant to go away from each other. So if you want to increase the distance like this or like this, greater the force here, greater the attractive force here, more will be the temperature requirement for this process to take place. And if this attractive force is lower, then it will require lower temperature to become liquid. Similar thing will happen here also. Now if we apply this one into alkyl halides, then what will happen? Let us consider any alkyl halide, and if we compare this compound with this CH3 CH2 CH2Br, this is one alkyl halide obtained from this alkane. Now look, in this is alkane and this is alkyl halide, everything remains the same, only here one hydrogen is replaced by bromine. So in this compound the molecular mass is greater. So since the molecular mass here is greater, so it will have more attractive force among different molecules. The force here among different molecules of this compound is known as van der Waals force, and due to this increased or more van der Waals force among different molecules of ethyl bromide, it will have higher melting point and also higher boiling point compared to this compound. Okay, so in this way, if we consider this type of compound Rx and RH, this is the pure alkane and this is alkyl halide, every time it will have higher melting and boiling point compared to this one due to the presence of stronger van der Waals force among the molecules of this compound. Now we shall discuss another type of compounds like this. Let us consider this compound CH3I. Now if we write down another compound having the same alkyl group, that is CH3, then CH3 along with Br, it will form CH3Br. Similarly, it will form CH3Cl, and if we take CH3F also. Now if we consider all these things, now generally these compounds may be regarded as this alkyl group, any alkyl group may be taken, but here we have taken the simplest one, methyl group. Instead of methyl, we may take any alkyl group here also, like R. Now in these cases, this portion, this and this is common, so they will contribute equally in each and every case, but the difference will come in this portion. Now since this one is the heaviest among all these halogens, so this molecule will experience highest van der Waals force among the molecules. So you have to apply more and more force, more and more energy rather, to separate them, resulting higher melting point and boiling point. Okay, so if we go from here to here, since this is of relatively lower atomic mass, so this molecule will have relatively lower molecular mass also, so it will have lower van der Waals force compared to this one, so it will be more easily converted into liquid and then gases. Okay, similarly if we proceed in this direction, then each and every time the molecules will have lower van der Waals force, and so most easily they will be converted into liquid and gaseous form. So if we go from this side to this side, melting point and boiling points gradually decrease. Now we shall consider another type of compounds, which will be again the alkyl halide type compounds, and here we shall change the reverse one, that is in these molecules this portion was same in every case, but this was not same, that was differing each time. Now in this time we shall do the reverse one, that is this halogen same, let us consider chlorine everywhere, but this portion will be different. So if we take different alkyl group, let us consider this is CH3 group. Now come to this, let us consider this is CH3CH. Now in this way we are preparing different alkyl halides, now where chlorine atom is same, that is halogen atom is same, but the alkyl group is different. Now if we move from lower to higher alkyl halides, then what will happen is that this portion is becoming heavier and heavier. So due to increase in volume of this, due to increase in number of carbon atom in this, they will experience more van der Waals force among different molecules. So what is happening in this case? Here the van der Waals force among molecules is lowest, and as we move in this side, here the van der Waals force among different molecules will be highest. resulting this one having highest melting point and boiling point, and here lowest melting and boiling point. So in this way, if we take same halogen along with different alkyl groups, then greater the molecular mass of the alkyl group, higher will be the melting point and boiling point of the compounds. Let us consider different alkyl halides having similar molecular masses but the structures differing from case to case. Now what are they? Now let's write this thing. This one may be forming this compound, now let us consider another one which will have similar type of number and similar number of carbon and hydrogen atom. Now consider these three compounds. Everywhere the molecular formula is same, the molecules are same, only they are isomer of each other. So what will be the trend of melting point and boiling point of these compounds? Now again in this case the key factor is van der Waals force. How that will be effective here? Now first of all consider this portion. Surface area here will be maximum, then it will have medium surface area, and here the surface area will be least among these three. Now just ignore my drawing, here it appears that it is having highest surface area, but in reality it will have the highest surface area, then this one, then this one. So due to this surface area, if one molecule of this comes in closer to another molecule of the same compound, then since the surface area is greater, so they will have greater force of attraction among different molecules. The van der Waals force between one molecule of this and other molecule of this will be highest here, and this one will have intermediate melting and boiling point, and in this case due to the presence of weakest van der Waals force among different molecules, so this will readily be converted at lower temperature, resulting lower melting and boiling points. So in this way we can explain the melting point and boiling point of alkyl halides where different chain structures are there. Now come to the next topic of today, and this is stability of the molecules. Let us consider these type of molecules R, I. Now if we take all these molecules, then what will be the stability of this? Now if we take specific examples, then it will be CH3I. Now what will be the order of stability of this compound? Now in this one is having highest size, and carbon in all cases will have the same size. Now since this one is greater, this one is smaller, this one is even smaller, this is smallest, so this molecule will readily be cleaved, this bond will readily be cleaved, and so this will take part in reaction very easily. Now if you move from here to here, this being relatively smaller in size and higher in electronegativity, the bond between carbon and bromine will be relatively stronger, so it will require relatively higher energy to be cleaved from here. Similarly, this will again require more amount of energy to be cleaved, and here most amount of energy will be required. So this will have least stability, and since this bond is strongest among all these, so this one will not be readily cleaved, so this molecule will be most stable among all these. So in this way we can explain the stability of different alkyl halides also. That's all for today. Bye bye.